Hello everyone, before we get started with the guide, I want to tell you a little about the working principle and some of the problems I faced during development. At the core is a printed torsion spring that rotates a wheel mounted on a printed bearing. To allow the spring to be wound up, a ratchet is installed that prevents it from moving backward. To wind the spring, we need a similar mechanism, but one that rotates in the opposite direction. It also has a ratchet and a spring that returns the winding chain back onto the drum. The bearing is essentially a kind of planetary gear system with a herringbone gear, which prevents the rollers from falling out. At first, I wanted to print such a bearing as a single piece, but because of the necessary clearances, there was too much play, and the wheel wobbled badly, rubbing against the shield. I also really wanted to make a folding handle, but it took some effort to make it reliable, while still transferring the pulling force to the braking mechanism. But as you can see, I managed to do it. And now let's move on to the print settings. For easier navigation, I've organized the files into folders, since there ended up being almost 70 unique parts. It's possible to print either fully 3D printed springs or parts designed to hold steel springs. However, the 3D printed springs actually work quite well. As usual, the parts are optimized for printing on an FDM printer with a build volume of 250 by 250 by 250 millimeters. But they can also be printed on smaller printers if scaled down. Almost all parts can be printed with a 2-wall thickness and 10% infill without supports. Some parts already have built-in supports that need to be removed after printing. Before starting, I recommend printing and calibrating the clearances on your printer to ensure smooth assembly. For this, you can use a special calibration model. I'll attach the link. A good result is when all the spheres rotate except for sphere 01. Sphere 01 either does not rotate at all or rotates tightly. The printed springs can be made from PLA or PETG, just like all the other parts. The steel spring parts consist of 2 printed pieces joined by a steel spring. There's not a huge difference between printed springs and steel ones. I developed it mainly for producing physical copies. The steel springs simply don't lose their elasticity over time, which makes them more durable. For printing, I've prepared planetary gears with different clearances ranging from 25 microns to 100 microns. If the calibration test shows good results, 50 or 75 microns will most likely work, but it's always better to check during assembly. The ring gear has a split that may need to be separated after printing if it fused together. Some parts also have built-in supports that should be removed after printing. Due to material shrinkage, certain areas may warp slightly. The supports are necessary to preserve correct geometry. The belt should be printed in TPU with 2 perimeters and 10 to 20% infill, which is sufficient. These parts are the most heavily loaded, so I recommend at least 4 perimeters and 30% infill for them. All other parts can be printed without any special requirements. As usual, I've specified the number of parts needed for assembly directly in the file name. If no quantity is indicated, then only one part should be printed. Let's begin the assembly. Apply glue to the parts that need to be joined. Insert the connector by pressing it in and attach the decorative cover style 1. You can use clamps to hold the parts in place. Repeat the same process with the other parts. take the central part of the shield and align it with the outer part. Glue the connector into the slots, holding it until the glue sets, or use a clamp. Personally, I'll be using a 3D pen. It's a very convenient and budget-friendly tool for joining printed parts. The main thing is to use the same plastic as your print. This method also allows you to separate the parts later by cutting through the seam. Repeat the same steps for the other parts, joining them with the decorative cover style too. For extra strength, I add seams with the 3D pen to secure the connectors more reliably. As an alternative, you can use hot glue. In the end, check how solid the part feels, and if necessary, add more glue where needed. I've also prepared parts for printing on large format printers with a build area of more than 300 millimeters. The assembly process is almost the same as with the smaller parts. By the way, I ordered the Elegoo Orange Storm Giga with a build volume of 800 by 800 by 1000 millimeters to print the shield parts in one piece for greater strength and simplicity. Next, glue the wheel hub to the outer part of the shield. As I mentioned earlier, there are different rollers for assembling the bearing. Start with the 75 micron rollers and position them opposite the notches on the sun gear. Then place the ring gear on top. If the rollers shift, adjust them, though extreme precision isn't necessary here. Insert the assembled unit into the housing and try turning it. A bit later, I'll show you how it should rotate. This is good rotation. And this rotation is too tight, but it will still work. In fact, over time the material will wear in and rotate more smoothly. However, the first option is better. The main thing is to make sure there is no play. If it rotates too tightly, try the 100 micron rollers. If instead you feel too much play, try the 50 micron rollers. Once you're confident that the bearing rotates well, you can glue it into the housing. Lubricate the rollers with PTFE or silicone grease. Let's start assembling the wheel. First, take the part that has recesses on both sides. There's only one part like it. Then insert the next part into it along the guides. Do the same with the remaining parts. I recommend first assembling the following parts without glue, right up to full assembly, to make sure everything works and fits together, and only then reassemble with glue. To secure the last element of the wheel, insert the retainer with the beveled side facing outward. Place the wheel so that the inner diameter rests on the table while the outer diameter hangs off the edge. Insert the bearing into the wheel. Then place the entire assembly onto the hub. If you want to use the 3D printed spring, install it into the bearing housing. If you want to use a steel spring, you'll need to assemble it. Insert M4 nuts into their slots. Screw bolts into them to press the nuts fully into place. Insert the spring so that the loop at the end of the spring fits onto the locating feature with the hole. If the loop doesn't fit, remove the spring, open up the loop slightly with pliers, and try again. I'll leave the spring parameters and a purchase link in the description. Take the printed washers, insert M4 by 8mm bolts through them, and tighten the bolts to secure the spring. The spring is installed the same way as the 3D printed one. Place the chain roller on top of the first spring. Insert the ratchet, then rotate it to check that the ratchet engages properly. Insert the ratchet of the main spring, and once again check that the mechanism is working correctly. If you want to use a metal spring, it will also need to be assembled. Insert the M4 nuts into the slots, then attach the spring with screws. Align the notch on the hub with the notch on the roller. The springs also have notches. Align them approximately. High precision isn't necessary here, and press the spring down so it snaps into place. Now let's move on to assembling the inner part of the shield. Insert the rod into the hole with the chamfer facing the guides. Insert the brake pad into the guides and secure the printed springs onto the posts. If you want to use metal springs, fasten them with M4's 8mm screws. The springs are the same as those used for the second spring of the rotation mechanism. Apply lubricant to the friction surfaces. Now let's connect the two parts of the central piece. By the way, if you have a large printer, you can print this part as a single piece. Align the two parts and insert the connectors. Then screw in 2 bolts from the other side. Next, install the outer shield parts around the perimeter and fasten them with screws, but don't tighten them completely yet. This will leave room for adjustment in case something doesn't fit correctly. Once you've made sure all the parts fit into place and everything looks good, you can unscrew the bolts, apply glue to the mating surfaces, and then reattach them to the central part. The main thing is not to get glue on the screws, otherwise they might get stuck halfway in. Glue the connector on the lower part of the shield. I'm using a 3D pen here, and also reinforcing the seams with it. Add glue or plastic welding to any areas that lack rigidity. Make sure the structure is solid. Insert the handle locks into their slots. At the end of the chain, there is a clasp. Insert it into the chain roller. Tie a thread or cord about 1 meter long to the end of the chain. And wind the chain onto the roller. Carefully pass the other end of the cord through the channel of the inner shield so that the chain doesn't fall off the roller. Gently place the inner shield onto the hub, aligning it with the marker while slowly pulling the cord until the chain comes through. If the chain gets stuck inside, try lifting the inner shield and pulling on the cord. If this doesn't help, remove the inner shield and repeat the procedure from the beginning. Tighten the main nut. Bend the clasp on the chain handle and thread it through a chain link. Then cut or untie the cord. Check that the mechanism works. For the handle, I made two designs. One simple version for wrapping with leather yourself, and another that already has a wrapped effect. Insert the button into the handle, then insert the rod. Place the handle into the inner part of the shield. Put on the second part of the handle and tighten the nuts. Now you can set the handles into combat position. Slide the handle fully into the vertical position and secure it with the folding locks. By pressing the button, you engage the brake column, preventing movement. Hold down the button, pull the chain, it will wind the mechanism. Release the button and the mechanism will start working. To fold the handle, release the locks and slide the handle slightly backward. Do not try to fold the handle from its fully extended position. You'll simply break it. Always slide it back in the vertical position first, then fold it. For the strap, there are two options. You can either buy a webbing strap or print one from TPU. If you prefer webbing, do the following. Thread the strap through the inner part of the shield and secure it with the buckle. There are also two buckle designs available, a simple one and one with a lock. The TPU strap consists of two identical parts. Just insert them into the slots and attach the buckle to them. Now insert the saw teeth. The teeth have two positions, open and closed. Hold the shield from the other side and press the tooth into place, repeating this for each tooth. After you've made sure everything works, don't forget to glue the bearing to the hub and the wheel parts, otherwise they may have some play. The button also has a brake hold mode. Press and pull the button toward you. This will lock it in place along with the brake. Releasing it will start the mechanism. Do not keep the button pressed and the mechanism wound for a long time. Printed springs may lose their elasticity. And of course, never store the shield in this state. Now you can enjoy your shield, and don't forget to leave a like.